input the other code, and it will store all of that, including the blanks, as one string array. So you can do it. It's just hard to do it when you're reading. Yes, sir. Okay. Okay, so this just shows, here's the command header. Again, this is such a nice feature of MATLAB. You can just type the name of something that you want to see, and it prints it. So the output of this line right here, header, is this right here. See, that shows that it doesn't store any blanks, because header is 3 by 1, or 1 by 3. The first one is PT pound, the second one is X, the third one is Y. If you print them, it prints them one after another, with no blanks in the middle. It does not store the blanks because of the print statement. But if you came over here and you typed headers of 1 equals quotation mark, space, 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 PT, space, space, space. When you print it, it will be space, 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 PT, space, space, space. So you can store blanks. You just can't do it with the read statement. Okay. Yeah, I don't know. Some of this stuff is it's a little carried away. It shows the maximum capabilities of these commands. Some of those capabilities, though, you have to really think hard about how you could possibly ever do it. Right? Just read the data. Why do I need to know how to do all those things and stuff? So I have some mixed feelings about spending too much time on some of the details of these commands. But anyway, so this closes and reopens the file. Then it reads it all in with one fscan function. So here's the first part. It reads all that stuff. Now it closes that data file. As you go through the data file, it goes through sequentially from top to bottom, left to right. Okay? So however much you read, you're that far down through the file. Let's say for some reason you want to go back to the top of the file and start reading again from the top. That's why you can close it. Then when you do the open command again, here's the F open. It opens it up again. When it opens it up again, you're back at the very top. So if for some reason you do want to read it in more than one place, that's why you do this. Okay? Okay. Yeah, I definitely agree with this. Only use it if you really have to. If you wanted to put in, what you could do, for instance, is, let's say you have a big data file, and the data has a lot of text in it, and there's blanks in there, and you really want those blanks in your string variable. Right? fscanf doesn't allow you to store blanks. It will only read the string variables without the blanks in them. So what else could you do with your data? You could open an M file, go in there and cut all of those lines that you want to store with the blanks out of the data file. Forget about reading. Go into the M file and put them in there in commands like this. A equals paste it. B equals paste it. And just store the whole line at one time in an M file. And then instead of opening the data file, open the M file. It's the same amount of storage. It doesn't cost you any more on your computer. Not that storage is likely a problem on your computer anyway. Right? So it's perfectly fine. The only reason why you might have to use fscanf is because somebody else is preparing the data for you and sending it to you. And so your only option is to take this data file from them and use it. You could still take the time if you wanted, just to go open your data file, cut out the parts that you don't feel like reading, because the reading isn't very convenient, and just stick it into an M file with the assignments in it. Right? And that's another way to get it in the program. Why not? We did some calculations for a type of satellite called SAMPEX. SAMPEX flies around the poles, north to south pole, and it observes things on Earth. As it flies, it needs to keep the sensors. There's cameras and there's other kinds of sensors, infrared and others, that have to always be looking at the Earth. So as it flies around the Earth, this is the satellite, it also has to rotate. Okay, now to keep it navigating, to make sure the rotation is occurring correctly, it has two kinds of sensors to measure the current angle and just make sure it's doing the right thing. It can be adjusted if it's not quite right. One of those sensors is called the sun horizon sensor. So it's a camera that looks right at the sun. And the sun appears in that camera as a horizon like this. It just sees part of the horizon. Depending on how that camera is oriented, of course, the horizon will shift a little bit. Okay? So by looking at the horizon of the sun, that gives it one measurement of an angle. But imagine this is the satellite. If that camera is pointing out sideways, by looking at that angle, maybe it can tell this kind of rotation, but it doesn't really tell it very much about this rotation or that rotation. So for that one, it uses something called a 3-axis magnetometer. Three-axis magnetometer is a compass. Probably everybody's used a compass at some point. The compass that we're used to using lies flat on the table, and it's got a magnet in it, and it points at magnetic North Pole and magnetic South Pole. That gives you one direction, but only the flat direction on the surface. Actually, the Earth's magnetic field is 3-dimensional. So you can build a fancier compass that's like a 3-dimensional even, and it'll give you not only north and south, but also other measurements of the angles. So this satellite flies around and it has these two sensors on it. One sensor tells it how it's oriented relative to the Earth, and the other sensor tells it how it's oriented relative to the sun. And with those two measurements, it can tell whether or not it's in the right position to look at the Earth. Okay, fine. No problem. Right? We're good. Problem. It turns out, off the coast of South America, out in the South Atlantic Ocean, something weird is going on under the surface of the Earth. Nobody's quite sure what it is. But if you get into this region off the east coast of South America, there's something called the South Atlantic Anomaly. What's an anomaly? An anomaly is something weird, right? Like, you know, if you grow rice, and if your rice is always like this, and one day you go out to your rice field and there's one rice and it's like this size, that's an anomaly. It's something really strange. It's way out of the normal. So in the magnetic field, there's something called the South Atlantic Anomaly. Your compass will be doing just fine, showing you north and south, and then you get above this part of the ocean, this part of the Earth, and all of a sudden your compass flips around and it points at just totally random angles. There's something weird about the Earth's magnetic field right here. So when that satellite is flying over that part of the ocean, one of these sensors doesn't work anymore. Only the other sensor works. Okay? What about the sun? Yeah, there's this other junk out in space, like the moon. Every once in a while, the moon gets in the way and you can't see the sun. Or Venus gets in the way and you can't see the sun. So both of these sensors can fail at certain times. So we were working on a project to try to help navigate this satellite through those time periods when it doesn't have one of these sensors. How are we going to do it? F equals ma, right? We all know this. So we have to figure out F equals ma for this satellite. It takes a huge amount of data from NASA. This is a NASA satellite. A huge amount of data from NASA to measure several cycles. So why am I telling you this long story? Because I've used that FScanF function before when NASA has sent me data files that have millions of numbers in them. I don't want to make that part of an file. It's just too big. I want to leave it alone as a data file. So that's a good reason why you might want to leave it as a data file and read it, because it's so huge. You just don't want to mess with it. Okay, let MATLAB read it. But I would agree that most of the time, you probably don't really need to use that FScanF function. You might as well just put it into an M file and define it right inside the M file. Why not? Okay. How are we doing? Okay, I guess see you again at 9 o'clock. No, I think the only thing I'm going to see at 9 o'clock is the inside of my eyeball.